Dear student, myself Rajendra Aaseri, I am assistant professor in computer science department at Government Bangar PG College, Didwana. In previous lecture, we started a concept on B tree and we discussed various advantage of B tree on B plus tree. In previous to B tree lecture, we discussed about B plus tree, and in that insertion and updation and deletion operation we discussed in B plus tree. Then B tree, how beneficial in comparison to B plus tree, all this we discussed with help of some example, right? B tree basically remove the redundancy in which occurred in the B plus tree, right? So till now indexing and hashing basics covered, ordered indexes, then B plus index file and B tree index file already we covered. After that we just started in the previous lecture multiple key access. So we are continuing from that topic multiple key access. What do you mean by multiple key access? So in this concept we use multiple indexes for certain type of query. Like one query is listed here, select account number from account where branch name equal to parish and balance equal to 1000. Okay, so this is the query written. This query will give all the tuples or all the record from the database relation account, and it will give the account number only corresponding to branch parish and having the balance equal to 1000, right? Now we can implement this query with help of various possible strategies for processing query. First strategy is use index on branch name to find account with branch name parish. So first use the condition on the branch name, and after that test the value of balance which is equal to 100 or 1000 or not. Second, use index on balance to find accounts with balances of $1000 and then test on branch name equal to parish. Third, use branch name index to find pointers to all record pertaining to the parish branch, right? Similarly, use index on balance. Now take intersection of both the sets of pointers obtained, right? Now indexes on multiple keys. So composite search keys are search key which contain more than one attribute. As the name implies, composite search key, it contain more than one attribute in it. Example, branch name and balance, right? Now next is lexicographic ordering. In lexicographic ordering, A1 and A2 are supposed attribute which is less than B1 and B2. If either two possibilities are there, either A1 is less than B1 or either A1 equal to B1 and A2 less than B2, means we need to maintain the ordering among the attributes. It is called as lexicographic ordering, right? Next is indexes on multiple attribute. Suppose we are taking an example here. Suppose we have an index on combined search key. Then combined search key is branch name and balance, right? Now with the where clause, we are writing a where condition where branch name equal to parish and balance equal to 1000. Now the index on branch name comma balance can be used to fetch only records that satisfy both the condition, right? Now using separate indexes in less efficient, we may fetch many records or pointer that satisfy only one of the condition. Yes, very important. Means here two conditions are there. One is on branch name and second is on 1000. So we required the index on branch name and balance which can be used to fetch only records that satisfy both the condition. Now using separate indexes in less efficient, or we may fetch many records or pointers that satisfy only one of the condition. Now we can also efficiently handle where branch name equal to parish and balance is less than 1000. But we cannot efficiently handle where branch name is less than parish and balance equal to 1000. This is very important. We cannot compare the string with comparison operator, right? We can use the comparison operator with the we can say with the numerical value, but with the string value comparison operator cannot be put. Okay, so second, first, where branch name equal to parish and balance less than 1000, it can be okay, but we cannot efficiently handle where branch name less than parish, it is not valid, and balance is equal to 1000. So we may fetch many records that satisfy the first but not the second condition. Clear? Next is non-unique search key. So there are various alternatives to perform this concept. First is we can apply buckets on separate block, which is a bad idea. Okay, we should just ignore this. Okay, by ignoring the bucket on separate block. Second, list of tuple pointer with each key, like extra code to handle long list. Second, deletion of a tuple can be expensive if there are many duplicates on the search key. Why? Low space overhead and no cost for the queries. Now next, make search key unique by adding a record identifier by help of the following alternative. First, extra storage overhead for the keys, simpler code for insertion and deletion, and it is widely used, right? Next is various issues are in the indexing, so some other issues are also listed here. First is covering the indexes. Add extra attributes to index, so some queries can avoid fetching the actual record, particularly useful for secondary indexes. Okay, now why? So you will come to know, it can store extra attribute only at leaf, means only at leaf node we can add extra attribute, right? Next is record relocation and secondary indexes. So in this we say, if a record moves, all the secondary indexes that store record pointers have to be updated. Okay, node splits in B plus tree file organization becomes very expensive. So there are some solution listed here. Use primary index search key instead of record pointer in the secondary index. This solution is very important. We need to use the primary index search key instead of record pointer in the secondary index. Extra traversal of primary index to locate the record. Okay, higher cost of for query, but node splits are very cheap. Now add record ID if primary index search key is not unique. Okay, now we are starting a concept of hashing. In hashing, what we do, we use a modulus function, then some parameter is there. Based on that, we can sort a particular record that in which bucket it is going, right? So there are two category of hashing: static hashing and dynamic hashing. Initially, or we were using the concept of static hashing. There are some disadvantage of using static hashing. After that we will introduce in the next lecture dynamic hashing, right? So in continuing the next topic, that is static hashing. A bucket is a unit of storage which contain one or more records. A bucket is typically a disk block. We used to say block. So similarly, a bucket is also a block of the record, we can say. So unit of storage which can contain one or more records. Okay. Now, in a hash file organization, we obtain the bucket of a record directly from its search key value using a hash function. So this hash function is very important. With help of hash function, we can obtain a bucket record with help of a search key hash function, right? Now hash function h is a function from the set of all the search key values k to the set of all the bucket addresses b. Okay, now hash function is used to locate records for access, insertion as well as deletion. So this hash function is very helpful while performing the accessing of the record, insertion as well as deletion, right? Now records with different search key values may be mapped to the same bucket. Thus, entire bucket has to be searched sequentially to locate a record, right? So means we can say that if there are a record with different search key value, then they may mapped to the same bucket with help of hash function, right? How? So you will come to know with help of example in the upcoming slide or in the next lecture, right? So one example is written here. You will come to know that how hash function can be implemented. So suppose in hash file organization of account file using branch name as key. Okay. So we will see the figure in the next slide. There are 10 buckets. If you see, there are 10 buckets. See, okay, and bucket numbering is start from 0, and we are doing mod by 10 because when we do mod by n, then possible results are from 0 to n minus 1. If you do n mod n, then the result will be 0. Mod means the remainder, right? So in this in the diagram is given in the next slide. So first we are understanding the concept, then we will do with the help of example. Okay, diagram. So in this account file there are 10 buckets. The binary representation of the ith character is assumed to be the integer I, right? Now the hash function returns the sum of the binary representation of the character modulo 10. So if you see h of Paris, h of Paris will give, so binary representation corresponding to all the character, and we will find the sum, and then we will do mod by 10. So suppose h Paris, the resultant is 5, h of Round Hill is 3, and h of Brighton is 3. Okay, now the next slide is given here. Next slide. See, in this example of the file organization, you will see account file and using the branch name. So with the help of the branch name, we are just what we are doing, we are just arranging it with help of. So see, Brighton and Round Hill, when we perform the sum of all the binary values corresponding to the character and mod by 10, then we will find out that the result is 3. That's why Brighton and Round Hill is put under bucket 3, right? Similarly, Redwood will get, when done mod 10, then result will be 4. That's why it will be put under the bucket 4. And same for the Paris is getting the result 5. Similarly, that's why bucket number 5, Manus is getting the result 7. That's why the bucket allocated for it is the 7, and for the downtown the bucket is 8. Okay, so in this manner we can just put a particular record in their corresponding record, corresponding, we can say, hash bucket. Okay, so that's all from this hashing concept. So we are just summarizing whatever we learned about today. Initially we started a multiple key access. In multiple key access we learned various strategy, that if there are more than one conditions are applied at the same time in a query, then we can perform in different order. Either first condition is satisfied first, after that holding that second condition, or first we are assuming the second condition hold, then we are proceeding for the condition first. Okay, and with third strategy is we can use some indexing and file pointer, and with help of that we can perform the we can say predicate or condition matching, right? Then how to implement the indexes on multiple keys, we discussed this, the lexicographic ordering I explained. Okay, then indexes on multiple attribute, how to put. With the help of query we understand that we cannot put comparison operator with the string. Okay, Then non-unique search key concept also we discussed. What are the various issues occurred, okay, and what are the various alternative possible for the non-key and non-unique search key, all we have done. Then covering the indexes issues we discussed, okay. Next is static hashing. We started how to convert a particular record, how to put a particular record in their corresponding bucket with the help of hash function we covered in this lecture, right? So static hashing in detail we done with the help of a example, right? In the next lecture some more concept on hashing we will be covering. Thank you.